starting with the panel discussion of this day, scaling up midstream battery manufacturing in India powered by CEEW. India is aiming to scale up battery cell and battery module capacity in India through various policy incentives and 100 plus gigawatt hours of battery cell manufacturing, and is expected to be set up in the next 5 years. However, the midstream manufacturing of cathode and anode separator, etc., is highly concentrated globally and technologically complex to indigenize. This session will deliberate on the steps that the industry, government, and academia can take in the short to mid-term. To discuss the same, may I please welcome Mr. Avishek Kumar, CEO and co-founder Vflow Tech. May I please also request Mr. Tejas Kusurkar, CEO and co-founder of Offgrid Labs, to please come up on the dais. Also, we have Ms. Sheetal Bhat, VP Catamaran, for the panel discussion. May I please request Ms. Rachel Jain, Sales Manager Battery Materials, South Asia and ASEAN, BASF. Also, may I please request Mr. Bibin, VP, Senior Manager Manufacturing Operations, Log 9. Also, to discuss the panel, may I please request our kind moderator, Mr. Rishabh Jain, Senior Program Lead, CEEW, to please come up on the dais. Unfortunately, we don't have Mr. Bibin, VP, with us for the panel discussion today. So, on behalf of Log 9, we have Mr. Pankaj Sharma over here. Thank you so much, esteemed panelists. Over to you, Mr. Rishabh Jain.
Thank you. Hello, everyone. I'm Rishabh Jain from the Council on Energy, Environment and Water. We are a non-profit policy research institute based in Delhi. We actively work on issues related to sustainability and climate change with both central government and multiple state governments. I particularly lead the team called Tech Futures, where we focus on critical minerals, supply chain and manufacturing of solar, wind and battery components. As the country tries to meet its NDC or the net zero targets, we are also aiming to indigenize various parts of the different value chain. One of the key components that will be crucial for our part to decarbonization will be batteries itself. However, while we have deployment plans or some targets or intent for the batteries both for EVs and grid scale, there are multiple challenges as we try to move upstream or maybe integrate backwards. We have a stellar set of panelists here who have already been in this space for many, many years now to throw some light on what worked in India or what is working in India, what has not been working in India, what are the best practices maybe that are being deployed globally, and based on some of these learnings, what can potentially India, industry and maybe academic institutions and think tanks like us can do as we move to indigenize significant part of the value chain for India, specifically for batteries. One thing I also want to mention is that typically when we talk about batteries, we automatically pivot towards lithium-ion batteries. Thankfully, we have some of the panelists who are from the battery industry, but not lithium-ion batteries, and I definitely look forward to hearing more from how the technology is doing, how you see the market itself. But again, welcome again to all the panelists and the participants. And I'll start maybe with Pankaj itself, because again, lithium-ion is supposed to be the technology of the future. But Pankaj, my first question to you, and also, I mean, while you answer, maybe you can quickly introduce yourself and the organization that you represent. The first question is that you are one of the few battery cell manufacturers in the country with huge ambitions, right? And it's not easy to be first in anything that you are, right? Activity that you may be doing. What are the challenges that you face specifically on the procurement side? I'm sure you're facing multiple challenges, but on the procurement side, given the scale of the manufacturing capacity that is in India right now, and maybe even going forward, would be a small fraction globally. So in terms of trying to identify the right vendors, chemistry for Indian conditions, etc., and how do you think we have the capability to maybe indigenize also some of these steps so that maybe your supply chain is more strengthened? So over to you. Thank you.
Thanks, Rishabh. Always great to be here. I'm Pankaj, one of the co-founders of Log9. Log9 is not one of the few, but the only one right now that produces and makes its own lithium-ion cells. So we are definitely the first in the queue in terms of innovation on cell technology. And the bigger question is how did we become number one? Because what was not happening? What is it that we did? And I think cell technology moves in 3 different stages. Stage 1 is when you try and build it in your labs. You make a small cell. You acquire the knowledge of how you're going to build a cell. But that's okay. You can, in academic center you can do that. But when you move it to the next level, which is something like a proto line, and I remember a couple of years back we acquired a 1 megawatt hour line, and for about 2 weeks we used to stand in front of the line and think about that. How can we change this line? How can I get more input and output from this particular line? So that suddenly from a cell chemistry guys, you literally become a machine optimization process driven people. And generally these are 2 different people. Chemistry guys are chemists, and then process guys are process guys, and never you don't have that personality come into one. When we went from 1 megawatt hour to 50 megawatt hour, it's like a nightmare challenge that stands in front of you. You have to do the same thing. You were mixing a cathode material which was 250 ml, and now you have to do it 5 liters. And I need to now look for a bucket. I need to look for a system that's going to, keep what Rachel is going to give to me and not break it down. You're buying such expensive stuff. So I think the challenge has been on, scaling process. In terms of, and when you start to scale, then that comes the big question is from where are you going to buy the raw material, at what quantity, at what quality. And I think in cell technology, your supplier base is your business partner, because you're really dependent on their intellect and their ability to give you the raw material. And they're fighting the war on your behalf. You're never going to a lithium mine and fighting it for yourself, but your business partners which are impregnating those materials, and they're fighting the price war. They are the guys that are having long-term back-end contracts with them. So depending on their business intelligence and their ability to execute is very high. And I think that has been the biggest learning for us, is that work with those supplier business partners who have depth of experience, knowledge, capital, and ability to take price shots. You see this little go like this way, you don't want your production to go, right? So who's going to take that shot? Who's going to absorb it? Who's going to provide you? When it's high, they will give you at the same rate. When it's low, they're going to give you at the same rate. So I think this predictability is what is the critical part of it. And coming to the last part, definitely there is a huge interest at Log9 to indigenize everything. Our heart beats in tricolors. And what we want to do is that by building cells in India, we even want to empower the supplier base that's from India, and you'll be delighted to know that out of the 9 or 10 main things that go into a cell, for almost everything, we have some early startups getting into that area. So we are now starting to invest our own capital and resources into those vendors and saying, yes, kind of, boot up. There are a couple of things that I can just source locally. And as per PLI, there is a requirement that 60% of your cell has to be indigenized. So the path to making cells in India is only through indigenizing supply chain, booting that knowledge that we have learned and pass it on to the supplier base.
Thank you, Pankaj. I'll come to Avishek, to you next. As I had mentioned earlier, many conferences, there's too much focus on the traditional batteries, or I would say lithium-ion batteries. But can you explain what are the key features of a flow battery compared to the typical batteries, and for what applications do you typically have the edge? But more importantly, what are the materials that are critical while you manufacture, and how would you distinguish either the technical challenges, or are they simpler compared to the lithium-ion batteries? And is it difficult to procure some of those, or is it fairly simple to indigenize?
That's a very complex question, Rishabh. Hi everyone, I'm Avishek, co-founder and CEO of Vflow Tech. At Vflow Tech, we are building a flow battery solution for stationary application. Coming back to your question, yes, there is a lot of lithium-ion batteries. It's not a technology of future, it's a technology of past. Today, the global capacity is 960 gigawatt hour, And that has evolved because of the EV race. So you need batteries. There are certain parameters in lithium-ion batteries which makes energy densities higher, which is used for certain specific use case, and that use case is growing exponentially. Now you're talking about net zero. Now net zero, it's a very complex problem. People are talking about 50 years, 60 years. One simple way is to power ourselves with renewables. Now that's not sustainable because it's not permanent. And you need a lot of batteries to support EVs. And these batteries are different applications. Again, stationary pumped hydro is their limitation. So there is a niche for long duration, and somebody has to develop it. And that's why we have technopreneurs and entrepreneurs like us to take that leap. Now, that's a technology game. When you develop a new technology for certain applications and you have proven it, where flow batteries come into picture is that it has a technology, it's a 20-year-old technology, people have proven that it has worked, but there was no application, as the application is evolving on long duration stationary application, particularly clubbing well with renewables. Now why I talk about renewables is that most of the renewable assets has 25 years of lifetime. You need to charge during the 10 to 12 hours in the daytime and then discharge it 8 to 10 hours. For those applications, flow battery seems more economical, cost of ownership is good. Now the question is that the technology has been proven, how do you scale it to make the cost reduction? And I take that pride because I started my career in solar, $4 and brought it down to 17 cents per watt peak. So I've seen it, and I realized from China is that if there is a demand and there is enough resources, you can reduce the cost on scale of manufacturing. Now coming back to your answer on the resource on technology. So I will be more specific on vanadium flow battery technologies. The reason we chose vanadium flow battery technology is the technology from a technological perspective, it's simple. Vanadium is on both the tanks, so there is not much risk. Proven for 20 years on some perspective. It's about scaling and engineering challenges. So our team has improved the efficiencies in the range of pumped hydro, so it makes more economical senses. Now the raw material that we use is vanadium, which is 15th most abundant element on earth and used in the steel industry to harden steel. In India, we have resources, but vanadium is also interestingly present in petcokes, so low-cost crude oil has a lot of vanadium, waste has a lot of vanadium. So we are working on those technology to generate vanadium from waste, and then the cost and the carbon footprint come down drastically. Rest are plastic and carbon, so we use membrane. Now the membrane has a technology which uses polymer, and it's very similar to fuel cell, but it has not been manufactured globally. So because of technology not adopted, the cost is high, and we are investing on developing those membrane technologies. If this polymer and the technology can be scaled, the cost will come down. And the second thing is carbon. So carbon is also used in graphite, and we are using carbon electrode, which can be used from plant, but technology needs to evolve, and it needs to be reached at that scale. And the energy storage is very complex because it's about power electronics. Power electronics for solar has come down. For energy storage, there are certain deviations. Not all batteries have the same voltage range, so you need to balance that. So there's innovation on the semiconductor, and if you're able to do this, so these are the three key components that drives the cost. And we have a roadmap to reach out to make it more commercially viable.
Thank you, Avishek. Coming to you, Tejas, now, could you also explain the technology that you're trying to develop and commercialize in the country? What are the key applications that you're looking for? But more importantly, why did you choose this particular chemistry? I mean, when, of course, applications and technologies like flow batteries, alternative technologies like flow batteries were also there. What was the motivation? And similarly, what do you face challenges in material procurement, if any?
First of all, thanks. This is a very interesting panel, as I was mentioning you earlier. There is lithium, there is vanadium, and now I represent Offgrid Energy Labs. I'm co-founder. We build zinc-based batteries. Now, zinc is a very interesting material. I mean, first batteries that ever were built were from zinc. Voltage cell, but when in the process, zinc couldn't take off because primarily batteries were used for three use cases: power backup use case, inverter, automotive use case, and then there are industrial use cases plus electronics. And batteries were designed the previous versions, it could be lead acid, it could be lithium ion, were designed for those use cases, those three use cases. And after energy transition, now there is a mobility use case and there is a stationary use case. And these use cases have a lot of, they require a lot of batteries, more batteries than they were required before for electronics, power backup, or automotive batteries. So now the goalpost has changed. Earlier goalpost was different. So we can't rely on same technologies that were built for earlier use cases or different applications and try and focus to build batteries for a renewable use case or performance mobility. So now chemistry also has to evolve. And when we started this back 5 years back in IIT Kanpur, we realized that we need to build batteries that use democratized materials. So when you start with that ambition that battery raw material has to be democratically available, your periodic table shrinks. There are literally 5-6 materials that you can choose from periodic table to build batteries that use commonly available raw materials. And we worked on a lot of materials, and finally we chose zinc. The objective was that we shouldn't use any material that is not available on, let's just say, India Mart. So if you browse any chemical, our chemical is, you'll at least find 30 manufacturers and numerous traders who are already using and selling those commodities. So that was one. Second is, at every point in time, you have to think of cost. Because, I mean, performance, yes, performance are needed. It's not a question, but everything ultimately boils down to cost. And there are two levels of cost. There is an upfront cost, and there is a total cost of ownership or levelized cost of energy storage. That is a function of what is the operating cost, what is the life of the battery, what is the charging speeds. So you have to give a battery tech for these use cases, especially stationary use cases, that actually delivers better upfront and better TCOs as well. And we designed this zinc-based battery specifically for those use cases where you can deliver better upfront cost and better levelized cost as well. And third is manufacturing, since this is, so we realized that there is a lot of capital needed, and it's not just capital, there is also a lot of technical know-how that is involved in building battery. I mean, there are so many stalls here. I was really surprised to see you can build every component of any battery tech here. But these machines are not enough. You need to go through that development cycle. You need to have that technical know-how to build any battery technology. And that is also a challenge. So what we did is we actually innovated on our own machines to build core components. It could be electrodes, it could be batteries, it could be current collectors, it could be separators. And that's how we build the technical know-how in every component that goes inside the zinc-based battery. We brand it as zinc gel. And so every component that goes inside zinc gel is built by us. So on these three levels, we did several innovations. Today we are at a stage where we have done field trials with customers, utility customers. There are oil and gas companies. And now we will be setting up our own pilot manufacturing here in Delhi NCR and take it to a next level, commercialize this time.
Very interesting. Rachel, I'll come to you next. Given that there's so much innovation that is happening in terms of the battery technology, not just within lithium ion. So of course, there's NMC, LFP, and multiple other technologies with contradicting predictions until 2030 and even beyond. What will be the market share of which chemistry? And then there are, of course, innovations in flow batteries, zinc gel, sodium ions, solid state, and whatnot, right? As a battery materials company, and as Pankaj pointed out, you have long-term offtake agreements from mines, right, for certain minerals, which then means that you have to maybe bet on certain chemistries. Accordingly, you would want to have back-to-back agreements, because if that particular chemistry does not find enough off-takers, what would you do with all the um, all the contracts that you probably have with your own vendors. Given such technological uncertainty, what are the strategies that battery materials companies like BASF deploys, or how do you even develop maybe the market, but internally what are the strategies, technological innovations that you deploy to shield yourself, but also maybe see that, okay, best batteries are also deployed in the world. So look forward to hearing from you.
Thank you. Hi. So maybe just first of all, a little bit about BASF. So BASF is a global chemical company manufacturing chemicals in multiple different segments with a very, very large portfolio, and we're doing this globally. Even in India, we already have 8 manufacturing sites, currently not yet focused so much on the battery ecosystem, but hopefully one day this would also happen and we'll be able to bring value to that in this country. Specifically to the battery manufacturing, here we are making cathode active materials, so we are the cathode suppliers specifically focused on high energy density solutions, so very much focused on NCM and NCA. Yeah. So back to your question about, especially I like your statement about the contradicting forecasts of NCM and LFP. Yes, I'm also having a lot of discussions with multiple people, especially the last 2 days, about, different people, different players have different type of ways of seeing it until the end of the decade. However, how we see it is that it's a growing market, right? It's not like it's a fixed battery market right now and everyone is sort of threatening each other's portions and market share. The whole industry is growing at the same time. And with that, so are the different technologies. That's what we're seeing. So I do believe by the end of the decade, every different type of technology and chemistry will have a decent portion and a decent role to play, with all of them with a significant amount of growth, at least until the end of the decade. And I think very, very often we see new technologies coming up as threats instead of as opportunities. Whereas I would say maybe there are more opportunities in this case instead of threats, because with the growing size of the market and just thinking about the raw material supplies that you have actually mentioned, you do need multiple and diverse chemistries out there so that you will have enough raw materials to supply the batteries market size, which is going to be huge by the end of the decade, looking at all the different types of applications. And I do believe each type of chemistry or technology coming up has its own use case, has its benefits, whether or not the customer is asking for better costs, better safety, better thermal management, looking at different regions in the world. I believe there will be different types of use cases popping up, and therefore that's how the different type of chemistries will serve those areas. So I don't believe it's going to all suddenly die out overnight. In that case, I believe it will be something that everyone is watching out for and looking at. I think what's very, very important for a company like us to stay aware of what's happening, obviously, is to be in very, very close collaboration with the entire ecosystem. Especially talking about customers, understanding what their needs are. One example is that, just maybe giving an example, focus on NCM itself. We're getting a lot of requests and working with global partners on just changing the composition within the NCM. I mean, we're still in the lithium-ion battery landscape. I'm not even talking about further chemistries yet. But even within that, we're getting requests to reduce cobalt, increase manganese. So even there, we're already developing different types of solutions based on the feedback that we're getting from the cell manufacturers, which they get from the OEMs, which they get from the end consumers, right? So I mean, this is a whole value chain that I believe every partner has to work well with each other. And I believe BASF being a rather big company and a company that's been around for a long time, we obviously have the opportunity and the resources in place to have teams working, especially very strongly in R&D, that work with academia, that work with institutions and small companies on seeing how the next generation batteries will come up. And when we find a viable solution that also fits a specific use case and there are customers that are interested in those things, those kind of products will become part of the roadmap eventually. And with that roadmap, obviously, then we will plan our strategies, right? And thinking of the raw material supplies, we will also obviously have partnerships in place to secure the necessary capacities. But like I said, that is all in discussions and all in collaboration with our customers anyway. So you have that kind of commitment downstream and upstream that's working both directions, I believe, and that's definitely necessary to ensure that you have the secured raw materials and the capacity to supply. And when it's the right time to make a shift, make a change, I believe that we will be aware and will be able to react accordingly when that happens. Yeah.
Thank you, Rachel. Sheetal, I'll come to you next. Pankaj, Tejas and Avishek maybe are outliers because they were able to secure the necessary financial support early in their startup journey or the company journey. But typically the financiers or the banks have shied away from investing in manufacturing facilities, specifically in technologies that have uncertain market demand. So right now we don't know how much EVs will be deployed, how much batteries will be deployed in the grid, and it will be very difficult for banks to agree even at higher IRR that they would want to lend money even at debts. So given all of this, of course, venture capitalists, angel investors, etc., are playing a very important role to scale up or to develop this market. But despite that, as you evaluate many of these technology startups, especially the manufacturing ones, what are the priorities that you have in mind, given the technology uncertainty that Rachel also mentioned? How would you bet on some of these organizations? Is it only the technology or the team or generally the ecosystem? What are the priorities that you keep in your mind, and maybe what are the priorities going forward for organizations like Catamaran? But yeah, feel free to introduce also on what you do and what does Catamaran. Thank you.
Sure, thanks. Am I audible? Perfect. Just for context, I work with Catamaran. Catamaran is a diversified investment firm. We manage the assets of Mr. Narayan Murthy. Our assets are today over $1 billion. We invest in bold ideas from passionate entrepreneurs and work with them across private and public markets to build successful enterprises. At Catamaran, we're extremely excited about the opportunity of investing in manufacturing. We believe that for India to reach its GDP growth ambitions, manufacturing as a percentage of GDP needs to grow from the current 15% to the mid 20% as in mature economies. We're particularly excited about companies manufacturing or building an indigenous supply chain in the electronic components and the electrification of vehicle space. Both these sectors are seeing great demand from domestic, international markets. There's the geopolitical situation, which is aiding the sector. And thirdly, the push from the government to kind of produce a bill manufacture in India so as to reduce the import bill and dependence on external supply chains. With that, the challenges that you talked about are very real. There are very few investors who like to invest in the space, primarily because these are long gestation investments, right? As a manufacturer, when you invest, it takes several years before you even recover your capital. And so as an investor, when we're looking at the space, we're primarily looking at four things. One is the addressable market. That is, how large is the opportunity? And we all discussed about how large, if you had to just talk about the EV cell or the renewable energy cell space, the market's expected to be anywhere from 6 to 10x of where it is today. So we're talking about a really, really large global market by the end of this decade. If you had to talk about India specifically, we're expecting that to be around 5% of that by 2030. And if you look at the announced capacities, and my number that I have is a couple of months old, but it was just around half of India's requirement by the end of this decade. So as you see, the opportunity is large enough. The supply is lesser than the demand that is expected to be there. So that's one parameter that we look at. The second one is traction on, is there some validation of what the company is building? So are there some marquee clients who have validated and attested that this company is building a high quality product, it meets some safety standards, it can deliver to the capacity that the entrepreneur is claiming? The third thing that we look at is the team. And over here, what we like is founders who have deep domain knowledge and expertise about the industry they're trying to disrupt or the industry that they're operating in. If you look at cell manufacturing, we're talking about multiple chemistries over here, right? We don't know what the future is going to be. Everybody's trying to take a blind bet. But we'd like to work with founders who have the DNA to evolve, adapt to what's happening in the market, and can pivot if required. So that's an extremely important trait to have. The last thing that we look at in manufacturing is fungibility of capex, right? It's capital intensive. We'd like to see that if the chemistry had to change in 7 years, 5 years, with minimal modification and additional capex investment, can this plant be modified, or can the capital investments be put to good use or an alternate use? So I think these are the broad 4 parameters that we look at when investing in this space.
Thank you, Sheetal. Taking a cue from what just Sheetal said, Pankaj, I'll come back to you. We don't have, of course, we don't have enough manufacturing capacity right now. And even we go with the announced capacities, including the PLI scheme, we'll not have enough domestic manufacturing, maybe by 2030 also. But all said and done, there are analysis, not by us, but outside, where we are saying that there'll be overcapacity of cell manufacturing, at least lithium ion cell manufacturing or pack assembly by 2030. Some estimates suggest by between 2030 and 32, the numbers may be touching 8 terawatt hour globally from the current numbers of maybe 1 terawatt hour. Now, of course, many of these planned expansions in Europe may not come along because of IRA, but still, we are talking about 100 gigawatt hours of manufacturing in India, maybe competing with factories of those sizes outside. How do you foresee that Indian manufacturers, including yourself, to compete with the global capacities like these? And this problem was also very similar to solar and still is. And what will give the competitive edge to the manufacturers? Price, quality, geopolitics. So what are your thinking, and what would your thoughts be and recommendation be to not just investors, but maybe new entrepreneurs and startups who would want to enter, but may feel dwarfed by that, where can we even enter this play when there's too many big players already in the system?
Yeah, no, that's a very relevant question, and I think we need to deconstruct that question a little bit, and rather than trying to find the answer, what should we do? I think what we need to focus is why should we do? There is a huge difference. Why did we go and set up our own cell line? It was 10 times more, 100 times more expensive to build my own cell than to buy it. There is a lot of production. There is about 350, 400 gigawatt hour of cell production that happens, and I can just go to China, take one flight. It costs me 50,000 rupees, and I can come back with a container full of lithium-ion cells. And I don't have to do anything. I don't have to deal with any input materials. I don't have to deal with manufacturing, scalability, manpower, electricity, carbon emissions, nothing. Why did I go ahead and even think about setting my own cell line? Why is India trying to set up its own cell line? Let the world keep producing, we keep buying. To understand that, let's understand what happens when you go to buy. When the drop goes to the ocean doesn't listen to the drop, right? Last year, India bought about 2 gigawatt hour worth of cells. World produced 400 gigawatt hour of cells. So when you're 2 gigawatt hour, you're less than 0.5% of the global production. When you go to the buyer, to the producers, who are you? Can you stand last in the queue, please? And by the way, I've got grade A cells. The Tesla guys are going to take it. Then I've got these grade B cells and these BYDs and all these guys, and and then your Tatas and Mahindras and Log9s, please come next Saturday to pick up whatever is left. The reason to go cell technology way is because you cannot get into the front of the line by your scale. You can get into front of the line by your capability of building it yourself. And what is required is when those technologies are being built, they are not being built for the drop. They've been built for an ocean which is sitting in a North American market or a Chinese market where the temperatures are 25 degrees. They don't need that much they can have an 8-hour garage parked car getting charged. In India, you and I park our scooters and cars 500 meters from our apartment. By the way, we're hanging up on the 14th floor. I don't have a garage. Where do I charge for that vehicle for 8 hours? So we fundamentally start to deconstruct India requires a certain kind of technology that the world's not going to produce. What we're going to compete is not on scale. Nobody is going to be out-competing an investment from a Chinese government in the next 20 years. But what we need to do is make in India what the Indian customer needs. You need smaller batteries, you need faster chargeable batteries, you need abilities to service those batteries, you need thermal cooling technologies that can control those cells. So you start to produce, and you need things at a particular dollar per kilowatt hour rate. So I think it's our inability to customize what we need that is going to assure the era of cell production in India. And by the way, coming back to the last question, the whole idea that there will be an oversupply. Today we produce 400 gigawatts of cell. Given every country reaches its net zero targets in the next 30 years, we would need close to about 35 terawatts. Where are we going to get that material? Who's going to produce that? That means we are producing 1% of what the world needs in the next 30 years. So you produce as much as you can. There is an off-taker, there is an absorber. All of these solar energies would require stationary batteries. All of our cars would require this. So the entire universe of our energy dominance has changed from liquid juices from the planet into this one simple thing that we call a battery, which could be a vanadium, lithium ion, whatever that may be. So I think two things, takeaways. One, definitely there's no obsolescence of will there be enough? And second is, let's stay to why do we do what rather than what we need to do.
Thank you, Pankaj, for those comments. Avishek, I'll come to you next. You've explained that, okay, vanadium is available abundantly, but are there any other critical minerals or materials that go into manufacturing? Even if not, what are the economies of scale that will be required for flow batteries to remain competitive with maybe the traditional batteries or maybe other long duration battery or settings like hydro in the long term? And what is the scale that you're operating, and when do you expect maybe you will reach that scale? Thank you.
Thank you, Rishabh. I mean, it's a very interesting question from economics of scale. One is on your own productivity, because your sales, general and admin cost for 1 gigawatt or 5 gigawatt are very similar. So that component you can reduce when you scale it up. Then there is supply chain. So though vanadium and other materials are available, same thing will happen what we are seeing in lithium ion in India. Though their materials are available outside, there is no supply chain. So then you start to import, all the cost adds up. So that part need to be solved. There was a very interesting study done by Nature Material because of the complexity involved in lithium ion making electrode, yield loss, so you have to optimize it. Vanadium will be competitive if you are able to reach 8 to 10 gigawatt hour. So currently China is ramping up about 2 to 3 gigawatt hour, and we are seeing a drastic drop because the membrane that was just used in fuel cell now being used in vanadium batteries. So the ability to produce more reduces the cost. So our estimate says if you have a 8 gigawatt hour ecosystem, you will be very cost competitive because the cost is driven by two factors: availability of materials, which for example vanadium is traded by metal, then the productivity and availability. So if there is availability, then you will be able to control, and the process cost. So process, and thanks to solar, 3 cents that you have in India, the cost of energy is record cheap, and that is making in India a very promising energy cost. Green and clean energy is effective. Chemical costs, these costs are again a factor of scale and local development. But to give you a factor, we will be cost competitive at 1/10 of what lithium ion is because of the simple nature of material that we use and less complex process.
Just one quick follow-up question to Avishek. Some of the things, say the components that may go into the battery itself, are you manufacturing those? Where is the manufacturing maybe of those components currently happening? And how technologically complex are they?
So one thing I learned in my PhD, that if you're doing an experiment, you solve one problem at one time. So this time, since we are about 100 megawatt hour of battery, we are building on technology, we are integrating materials, we are getting materials from different part of the world, like now Germany, China, but we have a roadmap to manufacture locally, so we are investing heavily on R&D which involves vanadium recycling, which involves polymer, and rest are plastic PP. So it's available in India. So we have started getting materials from outside, but with a roadmap, and our roadmap says that we will be planning to set up a 2 gigawatt hour factory in next 3 years, which will be a cost competitive. And idea is to integrate. And again, the problem is that if you become a 10 gigawatt hour, where is the raw material? So you have to secure it, that, and to be competitive like larger player, you need to control supply chain if you are becoming a manufacturing warehouse. So our roadmap also says that we will be integrating it all and be prevalent in at least key raw materials that we do and develop local vendors.
Thank you. I'll come to you, Tejas, next. Of course, we have spoken about oversupply and the ecosystem that may exist for lithium ion, and of course the economies of scale that are required. Both have their own trade-offs, right? If you have oversupply, which means the ecosystem already exists, you can maybe everyone in the ecosystem has matured to provide you products which are not only cost competitive but technologically better compared to the new technologies. Or if you have the capability to manufacture those, it's easier for. So to the technology that you're developing, are there similar startups or organizations globally or in India? And one is, of course, you can get some of these materials from India Mart or maybe other suppliers, but how easy or difficult would it be to scale up, say, until by 2030? Do you think some of those will also then become your business partners, as Pankaj would have mentioned? Or is this also something that you would want the ecosystem to develop more formally compared to maybe the lab scale that is operating right now?
Yeah, so on a first piece where use case specific, how does the alternative chemistries stack up against it? So what we have realized so far is customers don't care what tech goes, what chemicals we use. Ultimately, they care about, do we get the performance that is required at a cost that is beneficial. So we actually work backwards. Like we sit with customers, and these are large B2B use cases where we have realized there is a gap that other chemistries are unable to fulfill. It could be with respect to performance. It could be with respect to the thermal management that is needed. It could be safety in certain cases. So we built a customized solution based on our core tech to serve to that use case. That opens up a large segment for alternative chemistries in that space. On a second piece, for any start, zinc is not new. There are already companies in US, Australia, Europe who have been building and commercializing zinc-based batteries. So it has already gone through a, I would say, 15-year development cycle where there are commercial deployments that has happened at scale, and they've reached a level where today industry has realized that this is working. Now we need to work on how do we scale up? How do we scale up the manufacturing of this? Because raw material is not a problem for this chemistry. Raw material, in fact, there are a few partners here that we work with, which brings me to the third aspect. We believed that energy has always been an ecosystem play. No single player can handle end-to-end of that entire value chain. So very early in our journey, we partnered with key suppliers, key manufacturers who could build these batteries actually, taking this global later. We have worked with customers who enable or opens up large B2B use cases for us. So they are GTM partners. And third is into the power electronics piece, because if there is a new technology, it has to work with existing power electronics that is available. So if we build a new battery and if we ask, now you need a different inverter or a different BMS to be able to use these batteries, it's not going to work. So these batteries, the batteries that we have built actually use existing inverters, BMS, that is already built for, let's just say, lithium-ion battery or any other. And that way we have been able to identify and partner with key suppliers and developer in that segment and build an entire solution that specifically serves these niche but large B2B use cases. And manufacturing for us has always been, I mean, just few days back, there was a visit from a large battery manufacturer, and they were surprised to see that the innovations that we have made in even in manufacturing, because what we realized is you can make the best chemistry, but if it is not easy to manufacture, or it requires a very specific high-end equipment that India would never be able to build. And it's not just about India. Consider South Asia, consider Africa, Latin America. I mean, a technology has to have cross borders, and there has, I mean, somebody mentioned geopolitics. There shouldn't be any geopolitics, not just in raw materials, but also in terms of manufacturing. So that is something that we have been working on. It's a work in progress, but we're confident that we will be able to build a manufacturing process that is also democratized.
Thank you, Tejas. Rachel, I'll come to you next. And maybe if we talk about the battery component manufacturing, maybe the key components that are going to sell, we often, when we speak to many organizations, they would say that the facilities may not exist in India because, as Pankaj said, the demand maybe right now is not there. And even going forward, India will have a fraction of the total demand. But there are examples, and semiconductor industry is a very good example, where manufacturing facilities are globalized and set up in countries where the local demand is not of the same magnitude, very less. In that particular sense, what do you think are the key ecosystem enablers for organizations like you and maybe other companies, startups who are entering into cathode, anode, separator, electrolyte manufacturing to build in India, maybe not only for India, but for the world itself? What are the key building blocks that you think are required? Any learnings from outside, or what may work in India, what may not work in India?
Yeah. Maybe not even looking at the semiconductor industry, but just at the lithium-ion battery industry. There are some countries where the demand is maybe not yet there, but there are investments flowing in, right? I do believe that maybe that's also comparable for the situation in India, because I think in those countries, they have resources that people want that are being used in the lithium-ion battery. Therefore, due to some business factors, people want to be as close as possible to the raw materials as they can get. Because that also plays obviously a big role, and some of those countries obviously also have particular policies in place, I would say, that make it not so easy to just extract raw materials from those places. So I think that's also like one decision-making point of why people invest in some countries. However, obviously that's not very applicable to this situation that we have in India, especially if we look at what we produce. Nickel, cobalt, manganese is our main product, and lithium obviously goes into that as well. Currently, we don't really have direct access to those kind of raw materials here, right? So I'll come back to that, but I would say the first, foremost, what has to happen in the country, I think, is the demand growth, first of all, because India just being the sheer size that it is, I believe the demand is there and it's going to grow. And to be honest, I've been living in India now for the last 2 years, and what I've seen change in the last 2 years from an EV point of view has been tremendous, right? I mean, now you see EVs, I live in Mumbai, you see EVs nearly everywhere. The charging infrastructure is also coming up. I know people are complaining a lot, but maybe it's not fast enough, but it's there and it's coming, and you can see it coming. And I think the government is also doing quite a lot to encourage and motivate people, the consumers, to buy EVs more and more. You know, India has its net zero targets for 2070, which obviously helps companies also believe in the country that the demand is going to be there. There are programs in place like FAME and schemes that the government is doing in order to also make sure that not only the consumers but the manufacturers are also be able to benefit from that and set up their factories accordingly. Having said that, I think it has to continue. This demand growth has to continue, because I think that's the fundamental attraction for business decision makers, that that you're going to be able to sell your product in those locations accordingly. And once that's there, I think then it becomes interesting for whether or not global or local players, right? And I believe that there's a lot of belief in that at the moment. That's why you see a lot of players like popping up at the moment. Now coming back to the supply chain topic, obviously that is a challenge. Yeah? So I think that that's something that companies have to work on. And having said that, you know, a company like BASF, we do have partnerships in place where we're securing our raw materials that we need. But I believe that just working as a company alone on that is not enough. We need to work with the entire ecosystem. Everyone needs to come together. And I think that this is, you see it happening already in India, but I think it could be even more. I think that companies could come together even more to really see what can be done to ensure that the value chain is being built locally, because that makes it also easier, especially for a company like ours, because when we look at investments, when we look at where we're going to put up a plant next, we're not just looking at one country, we're looking at the whole global scale. So those kind of factors obviously come into play. Where are we going to get our raw materials from? Not only where the customers are. So this is a very big topic for us as well. And when we talk about building up a value chain, we don't only want to build whatever value chain up, but it has to be a sustainable value chain, and it has to be a secure and something that's going to be long-term. And when I say a sustainable value chain, I think that also goes back to, okay, why are we doing this? If I do put up a plant, am I going to get renewable energy to source, power for my plant? Because this is also something that I think plays a big role. Obviously, EVs is just one element in the whole big picture of carbon emissions, but obviously when we build batteries, it's rather energy intensive. So if we are able to get as much renewable energy as possible to source into the plants, obviously that is a very big plus point for decision makers as well, why you would want to build in those countries. And it should also be a circular value chain. So I think that's something that where recycling would also come into place. And I think that makes sense for India in the long run, that don't only look at the picture of putting up individual plants for the different value chain sectors along the line, but trying to close that loop within the country. And because especially you can't get those raw materials so easily here, once they're in here, I would say keep them in here, right? So keep them in the country. So I think that's also something that has a lot of potential to support the ecosystem here and encourage players to make decisions when they're thinking about where to put up the next plant.
Interesting. Thank you, Rachel. I'll come to you, Sheetal, next. Some of the things that all the panelists have said and reiterated is the importance of ecosystem and of course importance of investors also. But despite all said and done, there's much that needs to happen over the next decade specifically. And thankfully there's also this China plus one sentiment that will maybe help many of these facilities as tailwinds to scale up the facilities itself. As an investor, is there a more strategic view or investment decisions that you make? Say for instance, one, how would helping them, some of these, your companies to support in the whole process, but also when you're making, I think you mentioned $1 billion investments, but are you also then strategically making investments where you also then develop the ecosystem? So maybe in a cell manufacturer, but maybe in an EV company, maybe in a materials company, and follow on, so that all of them connected, but also if one grows, maybe the other will also then get supported. I don't know about, maybe not Catamaran, but maybe others. And do you think if all of the investors specifically start playing, and I don't know if startups or companies would want that, but would that be helpful? Because as we try to scale up manufacturing, all of these things need to come together.
Okay. So, Rishabh, thanks for the question. I think you raised a very important point that, Rachel talked about how it's, when they're making their investments, how they need to take a call on the entire ecosystem on whether there'll be offtake and it's viable for them to make that investment. Very similarly, from an investor point of view, we're looking at multiple parameters, right? I touched upon them earlier. What's the capital outlay? Will the company be able to raise money for manufacturing? Does the team have agility? Where's the raw material going to come from? Where's the demand going to come from? Are they truly capable of building a cost-competitive, high-quality product that can be exported? So there's so many parameters that go into when we're trying to make an investment, because when you look at it from a private market perspective, an investment is held for anywhere from 7 years, 10 years, 12 years, longer than that, right? So you want to be sure, at least have reasonable certainty when you're trying to make that investment. And today, when you're looking at this ecosystem, there are multiple challenges. We were discussing earlier as well, right? There are multiple players in this ecosystem. You can look at the OEM, you can look at the cell manufacturer, you can look at the battery manufacturer, you can look at the charging station. There's so many people, and all of these guys have to come together for this ecosystem to do well, right? And as an investor, we'd be more than happy because to kind of look at the entire ecosystem, because then it's solid, it's strengthening the whole thing. So we are actually, that's how our thesis plays out, which is go back and try and figure out what is essential to developing this whole ecosystem. If you just look at the move to EVs, if you look at the top auto companies by market cap in the US 3 years back, it used to be Volkswagen, Mercedes, and the likes. If you look at it today, it's Tesla, BYD, LG Chem, right? So there's this value migration happening. So we know that for India's own reasons as well, right? The government push, independence, energy independence, reduce of import bills. There's this massive push towards electrification, renewable energy, and hence we know it makes sense to kind of work backwards and try and support and build that ecosystem so that we can see that vision of the whole story playing out. So as an investor, we're open to these ideas and willing to support them.
Thank you, Sheetal. We may have a couple of minutes, so unless someone has a burning question, we can take maybe one or two. So if there's a mic. Anyone else who would want to ask a question?
Hi, my name is Kunal. I come from a green tech company called Molson. I am pleased I stayed back for the third day for a conference. This was one of the most exciting sessions. Thank you. The question is on two fronts. One, to Sharmaji, thank you for validating what the role that suppliers play. I'm curious, do you see biomaterials becoming a form of supply chains across different components of batteries in the decade to come? For example, chitosan has been heard to be used to increase silicon content. It has been talked about in electrolytes. Do you see any biomaterial getting into the battery supply chain? Is there any chatter that you can throw light on? Second question is, perhaps Rishabh, you can advise who can be the right point. You see a lot of news and charcha on vehicles being electrified, but very little is being spoken about, at least on the larger media scale, about ESS opportunity. Is it just economics that is stopping energy storage systems to become the big part of the conversation? Because I don't see why that segment of 200 gigawatts, let's say by 2030, is not getting as much attention as it should. Perhaps these guys are working towards it. A little bit of conversation there.
Okay. Who was the first question to?
Do you see any scope in biomaterials?
To BASF.
To Sharma.
Rachel. Oh, Pankaj.
Even perhaps Rachel could come in.
Yeah, it won't be great that if microorganisms like bacteria can make batteries for you. Right? Raw materials that can come from oceans and all that stuff. But I think some interesting stuff's happening there. So there is an effort that's going on in terms of microorganisms that can break down stuff like sewage water and other contaminated stuff and then get a hydrogen release from it. So there is a biosynthetic way of getting green hydrogen. So I think that's gonna take off. So when something is very basic like a breakdown metabolite material, that probably will enter into supply chain in some kind of energy form. What goes into batteries are extremely pure materials, 99.9%, 99.7% pure materials. And biology is designed not to give you specifics, but diversity, right? So you get a lot of other stuff that you have to purify, and sometimes the cost is too high. So I think in my perspective, these are early years. We haven't really tapped into the intelligence of biology to give us what we want. So I think basic stuffs like hydrogen and some of the other stuff will come out. Kerosines and other things may start to appear. We may get some catalysts that are bioproducts that you use in your chemical processes to process some raw materials. But that's pretty much the visibility that we have at this point. At least I only have that visibility.
Yeah, so great question, by the way. I mean, there are very few who, look back and, so basically in our batteries we use carbon, a lot of carbon. And carbon is we get it from activated carbon sources. So, and this is a coconut shell product. So yes, we do have a huge content of carbon that we use in our batteries, and that is a bio material.
I mean, just to add on it, because organics, it's a very interesting proposition because it complements the natural resources. The thing with organic and bio is the stability, and battery needs stable. So that's R&D part that people are working on it. I mean, there's from organic flow batteries are showing stable performance. There are certain effects, but it is getting integrated. I mean, from a commercialization perspective, about 10 years, there are certain issues to be solved. Coming back to your second question, which is very interesting. I mean, energy transition is where you have a lot of renewables. And then there is a commercial sense. So if you add batteries, solar is cheap and you can put it more. It's with your bad battery, that's extra cost. So there's a cost goes high up in the market. So there is, so that is economics is not working in most of the cases where you are talking about traditional grids. But what is happening is there is external factors that are changing. For example, steel manufacturers, CBAM is coming up, so they have to sow net zero. And from that perspective, demands are building up. You will see about, I mean, India is very interesting. We have solar, we have wind, you combine it, the battery requirement 6 to 8 hours. And that's evolving. So that has not evolved in the past. Our renewable penetration was also low, and it's evolving. So that demand is coming up, forward looking. And there are right steps being done. VGF is one of them. And I'm talking to most of the large developers where they are talking about it, talking about RTC, and the requirements are coming up. One more thing that is coming up is that as renewable integrates into grid, different DISCOM has different renewable integration. So transmission and distribution is coming up. It has come up. I mean, as of now, the market is not there. Economics changes, and pumped hydro, you will look into very interesting that round-the-clock solution comes to about 9 rupees. So batteries are getting in that context, and it's evolving. As of now, it's in next 2 to 5 years, I think that will become more competitive, and that will there. So we are moving in the right direction. China has shown it, so they have deployed a gigawatt hour almost every month for their grid and for the renewable integration. And they are using batteries just for renewable integration from that particular perspective. So that will happen, and that's why there is a need to ramp up the local demand, and that's why we are here.
Just to build on that, actually, we are making progress on energy storage, and there are tenders being awarded in energy storage. Recently, I think NTPC launched 9 gigawatt hour tender. I think that's world's biggest energy storage tender ever, 9 gigawatt hour. So things are happening, and yeah, we're there, I would say.
Thank you. So with this, we'll end the panel discussion, but I just want to mention that over the many years that at least I've been working in the industry, I've not seen the kind of traction and momentum for both manufacturing and even for energy storage, both for grid scale and EVs. Thankfully, I mean, even though there's no clear target for EV at a national level, and for many states, still EV is being deployed at a pace that is encouraging. We may not be there, but it is definitely encouraging. It has also happened because of commercialization of the technology, because economies of scale make it work when for people who would want to shift to ICE. And thankfully, because of the many innovations that are now happening in India and for India, we may see many of the technologies getting scaled up, commercialized, economically viable by 2030, even before. And once that happens, we are very hopeful that maybe we'll have more jobs. We didn't get chance to talk about skilled labor and the benefits that it will have for economy. But we'll have more discussions on that. But thank you again. I learned a lot. I know we've been interacting bilaterally, but I learned a lot in the panel itself, and I hope everyone who was there for one particular hour, it was useful for your time also. Thank you again.
Thank you so much, esteemed speakers, who have shared such a beautiful discussion in front of us and the audience today. I'm sure each and every person sitting over here in the audience are truly mesmerized to know the details on how the battery world is totally evolving in India and beyond. May I please welcome Mr. Rajneesh Khattar, Group Director, Informa Markets India, to please come up on the dais and share a vote of thanks to our esteemed panelists today.
Thanks, Koelika. You know, all through this last 60 minutes when I was part of the attendees, there was one thing which was coming to my mind. You know what, before I came, I imagined that this is one more panel discussion, and I was talking to my team. I said, don't do those panel discussions on day 3, right? You will not get attraction. Because normally in our kind of industry, day 1, day 2 are supposed to be, you know, the kind of, they take away the maximum traction. But I think I was wrong. And trust me, this was not a panel discussion. It was much beyond. It was, to me, it was like a master class. And for the first time, I was wanting to put the timer on the stop so that it doesn't show that what time we are. I'll just pick up from, you know, this is my observation. I'll pick up from what Pankaj said, and I think I'm going to use it time and again moving forward. He said our heart beats for the tricolor. He said if a drop goes to the ocean, ocean says who you are. So in our bit of effort, we have brought the ocean into India. We have brought the ocean to meet the drop so that this drop gets merged with the ocean, and tomorrow we have an ocean in India. I think the way India is rising in the investment attractiveness index worldwide, the kind of limelight what India is gaining these days, I think we have the capability and capacity to change the headlines. It's only a matter of time. One more feature before I go to the ceremonial part of it. I mean, what amount of clarity these guys are having in mind. The roadmap is so very clear. What's happening outside is the transactional business. Very important. It's important that industry grows from there. But the fundamental of that, what's happening on the floor, comes from here. This is a knowledge powerhouse. And I'm not only pleased, I'm privileged that I'm part of from the audience, and it's my true pleasure. Looking at the average age of the panelists, they don't have any legacy of their parents. You know, some kind of a family business. They're not the family Shyams. Not coming from Ambani's, not coming from Tata, not coming from Adani's of the world. They're charting their own paths. And I don't want to stand between them, between you and the lunch. We have this, one of our athletes who has just won a gold medal in the 3,000 meter steeplechase. Avinash Sable, I don't know how many of you heard about him. He isn't that popular. But when he won the gold medal at the Asian Games, he says, until now, I was following a path which was set by others. And this morning, before the race, he spoke to his mother. He says, my mother said, today is the day when you chart your own path, set your own path. And when he came out with the gold medal, he said, I have nothing more to say. But today I decided to chart my own path. I think this is the time when India can chart its own path, and all this will come from here. Thank you so very much, and I'm honestly speaking, I'm extremely impressed, and thank my team who has curated this wonderful panel, and Rishabh, the way you have conducted this panel. And before Sheetal came on board and she started talking about it, I was just scratching my head. I said, I really wish, because all the technocrats talking to each other, I said, I really wish there could have been someone from the finance, someone from the investment fraternity who would have listened to them. And I apologize on behalf of myself that I didn't know that Catamaran is into financing. They're into the investment business. But the moment she said that this is we are, I said, oh, I think now it's comprehensive, it's 360 degrees views. Thank you very much for being so patient. You know, I know it's not easy, but I can see that we are all going home, we are all going back much more richer, at least myself, and I take pride that we are trying to put our best foot forward, and look forward to, you know, many more sessions, I think, which are coming after the lunch, and next year we'll have it even bigger, better, and that's what I can promise on behalf of. Can we have the ceremonial gesture, please?
Very kind words from Mr. Cutter. Can I please request Mr. Rajneesh Khattar to hand over a token of appreciation to our kind moderator, Mr. Rishabh Jain, Senior Program Lead, CEEW. May we also request Mr. Khattar to hand over a token of appreciation to our panelist, Mr. Avishek Kumar, CEO and co-founder, Vflow Tech. May I request Mr. Khattar to hand over a token of appreciation to Mr. Tejas Kusurkar, CEO and co-founder of Offgrid Labs. Can we please hand over a token of appreciation to Ms. Sheetal Bhat, VP Catamaran. Also, requesting Mr. Khattar to hand over a token of appreciation to Ms. Rachel Chen, Sales Manager, Battery Materials South Asia and ASEAN, BASF. Now may I request Mr. Pankaj Sharma, co-founder Log9, to please come forward as we give you a token of appreciation on behalf of Informa Markets India. May I request all the esteemed speakers to please come forward for a group opportunity picture so that I also request Mr. Amit Sharma, heading Conference Division for Renewable Energy and the Battery Show India, to please come up on the dais.